Hello Calc kids, welcome back to another lesson in calculus. In today's lesson we're going to talk about the second derivative of a parametric equation. So last lesson we did the first derivative, this lesson we're doing the second derivative. It's actually not too difficult except for the fact that you have to really pay attention to details because there's just little places you can make mistakes. So it's not that it's hard, it's that it's hard to keep track of everything you're doing. And so if you speed through things and get a little bit sloppy, you're the ones that will probably make more mistakes on second derivative for parametric equations. I'll try and point out specifically where the most common mistakes happen on this. So what we're working on is how to take the second derivative. So the way this works is you take the derivative of dy dx. So you take the derivative of this. Well, this is a little bit weird. Like, how do you take the derivative of dy dx with respect to x when it's actually with respect to t? So dy dx is going to be with respect to t. So this is how you do that. You take the derivative of dy dx with respect to t and divide it by dx dt, the derivative of x with respect to t. Okay, so this looks really confusing. So let me see if I can help you by just saying another way of thinking of this. After you find dy dx, okay, so you find dy dx first, and then you just take its derivative. That's what you do for the numerator. In the denominator, you take the derivative of x with respect to t. Okay, so that's what we're going to do. We're going to find dy dx, and then its derivative goes in the numerator. And then you go back and look at what was your x of t. Its derivative is what goes in the denominator, and that is the second derivative. Okay, so I think this way is a little bit easier. Technically, this is what it is, but this might make it a little bit easier to remember. They mean the exact same thing if you look carefully at it. All right, so get that written down if you don't have it down yet, and I'm going to go and do our first example. First step is take dy dx. Let's find that thing. So if you remember from our last lesson, that is taking the derivative of y, so that's this part. So if I think of this 1/2 as distributed through, then its derivative, well, that's just going to be a t, right? Because that's going to be the constant, the 2t times the 1/2. Okay, so then we go to the derivative of x. That's what goes on bottom. The derivative of this is 1/2 t to the negative 1/2. So there's my dy dx. And let's try to simplify this before I go on to the second derivative, because it would help me quite a bit to have this simplified. Let's see here. If I divide by a 1/2, that just means 2. And then this is going to be t raised to the negative 1/2 joins the 1 that's on top. So that's now 3/2. I'll add the exponents. 1 plus 1/2. All right, so there's my first derivative. The second derivative now, so let's start writing that out. Second derivative of y with respect to x, and then we square that one, so that's my notation. So now I'm going to do, on top is the derivative of my dy dx. So I'm going to take the derivative of this with respect to t. So the 3/2 comes down and times it by 2, so that just leaves me with 3t raised to the 1/2, subtract 1. Now on bottom, this is where the most common mistake occurs. And that is remembering that this right here is x prime of t. So you go back to what x of t was, square root of t, and you take its derivative. 1/2, and then t raised to the negative 1/2. That's what goes here. Most common mistake is that. And then the next mistake would just be simplifying correctly. But this is really it. So if you notice carefully here, you've actually already found x prime of t when you found dy dx. It's this denominator right here. It's the same. Those two things should be matching. So when you're done, double check that you have the same thing there. Done as in before you start simplifying. Okay, so but I always go back and look at what x was and then take its derivative just to make sure that I'm keeping track of everything. All right, now we just simplify and we're all finished up. So this 1/2, dividing by 1/2 is the same as multiplying by 2, so this just becomes 6t raised to the 1/2 plus 1/2. I'm going to bring this one up there. So the negative becomes a positive and we're adding it. So the answer to this is just 6t. And that is the second derivative. Now, what does the second derivative let us do? It lets us find things like concavity, points of inflection, things like that. So if you go back to our first and second derivative tests from Unit 5, that's what this is going to let us do. And that's the type of problems usually you would see on an AP exam, something dealing with the second derivative. So you just want to keep that in mind. All right, let's do another one here. This is a good one to show you why the importance of simplifying can help us quite a bit. So first, find dy dx. So I'll create my fraction here. I'm going to find y prime first, y prime of t. So that's just a 4 cosine t. And then I find on bottom the derivative of x of t, which is going to be negative 3 sine of t. And then I can simplify this now. Let's simplify this to negative 4/3. Cosine over sine is cotangent of t. I'll put that one in parentheses because there's too many t's going on there. All right, so negative 4/3 cotangent t. Now we go to the second derivative. So second derivative is going to equal, now I have my fraction, and what goes on top is the derivative of dy dx. So the derivative of this thing, negative 4/3, now going to become positive because this starts with a c. Derivative of cotangent would be a negative. That's why the negative's gone. Cotangent. Tangent is secant squared. So cotangent is cosecant squared of t. That's just the numerator. Now the denominator should match this one, but let's just double check. Go up to here to x. The derivative of this is what goes on bottom, so that's negative 3 sine t. All right, so this is the second derivative. There'll be times where you have to plug something into the second derivative, and it would be nice if you can simplify this. So one way we could do this is change everything to sines and cosines. Change this to 1 over sine, like 2 of them, and there's another 1 over sine here. Or if you remember, sine, the reciprocal of sine is cosecant. So if I can flip this thing, so in other words, the second derivative of y with respect to x squared equals, so let's do the numbers first, for negative 4/9, because this is the same thing as multiplying that by 1/3. So it's negative 4/9. And then this sign can come to the numerator if you change it to cosecant. So if it becomes cosecant, there's now 3 cosecants in the numerator. So it's negative 4/9 cosecant cubed. Okay, the other way would be change this to 1 over sine, and then there's another 1 over sine. So there'd be 3 1 over sines, which is the same as cosecant cubed. Okay, so a couple ways to manipulate it, but so whenever you have sines and cosines, you want to try and simplify it down as much as possible. It makes it easier for when you have to plug things in to the second derivative, or it makes it easier to take the second derivative itself. All right, one more problem, and that is dealing with concavity. So now we will apply second derivative test here, but we're just plugging in a t equals 1. So instead of finding where is it concave up or concave down, we're just trying to say is it concave up or concave down at that point t equals 1. So we start off, to find the second derivative, we need the first derivative. So let's see derivative of y prime of t, that is 4t cubed plus 1. And then the derivative of x prime of t, that's just going to be 3t squared. And I would recommend we simplify this before you continue on, because if you take the derivative of that, you're going to have to use quotient rule, and that gets really messy. So if you can simplify, please do it. So that means we separate these fractions. This over 3t cubed, that's just 4/3 t plus, and then 1 over 3t squared. And I'm going to change that to 1/3 t to the negative 2. I'm going to change it that way because I know I'm about to take the second derivative of that. So if I write it like that, it'll help me to calculate out what the second derivative is. So d squared y dx squared equals big fraction. Now I take the derivative of this. That's what the numerator is, the derivative of dy dx. So that's just 4/3. And then the derivative of that piece is negative 2/3 t to the negative 3. And then on bottom, what goes down here? X prime of t, the derivative of x. So that's just 3t squared, and yes, it matched with that one, so that works. And now what we do is we're just plugging in a 1, so d squared y over dx squared, and I'm going to put a little line here and evaluate it at t equals 1. So this is just a way of saying we're evaluating second derivative at the point where the time is 1, or t equals 1. So that equals, so this is a 1 and that's a 1. So then we just start working through and do a little bit of arithmetic and simplify this. 4/3 minus 2/3 times 1, all over 3 times 1. So then that equals 2/3 divided by 3, or in other words, multiply by 1/3, and that equals 2/9. Now, the point of this was to find the concavity. In other words, is it concave up or concave down? This thing is concave up, right? At t equals 1. It's concave up at t equals 1 because the second derivative is positive at t equals 1. So that's how we know. Okay, so we covered it all. So again, let me just remind you, when you're doing the second derivative, most common mistake is making sure you accurately put down x prime of t on bottom. So don't forget that. Take the derivative of dy dx, and then in the denominator, plug in the correct x prime of t, and then simplify from there. Okay, rock that mastery check. This is Mr. Bean signing off. I'll see you back in the next lesson.